Hello and welcome to part 2 of IAL EDEXCEL AS Levels Physics Paper 1, October 2024. This is WPH11/01, Unit 1. Part 1 we have already done, in which we have completed 10 MCQs. Today we will do part 2. Okay. So, question number 11. Two forces act on an object. The forces are perpendicular as shown. Determine the magnitude of the resultant force using a scaled vector diagram. For the scaled vector diagram, you must remember that you need to choose an appropriate scale. Okay. So, I'm choosing 200 newtons equals 1 centimeter. So that will make this vector to be 6 centimeter and this vector to be 11.5 centimeter. Okay. I have now two vectors here. So this is 1, 2, 3, 4, 5, 6, for example. And then, for example, you can say this is by your scale. Okay. You need to draw these two lines by your scale. And you need to connect these two vectors by head to tail. Okay. Because tail of second vector is connected with head of first vector. This is called head to tail rule. Now, according to Pythagoras theorem, because these two are perpendicular to each other, 6 square plus 11.5 square will be equals to 12.9 centimeter. So your resultant vector should be all the way here, and with your scale, you have to extend it up to 12.9 centimeter. Okay, and this 12.9 centimeter will represent 2594 newtons. Okay, which is the resultant of 1200 square plus 2300 square, all in the root to be equals to 2594 newtons. Okay, it was an easy question, not that difficult. Okay, so uh-oh. Please wait. Yeah, this is much better. Okay. So, question 12. Question 12. A student has a spring of length 0.18 meter. The spring has a stiffness constant of 95 Newton per meter. The student applies a force of 7 Newton to stretch the spring. Calculate the new length of the spring. So they're talking about new length, not the extension. From Hooke's law, you need to remember that F equals K delta X. What is force here? 7 Newton. And what is spring constant or stiffness? This is actually 25. This is 25. And this is extension. Okay, so 7 by 25 equals extension, which is equals to 0.28 meters. Now, what is extension? Extension is actually the change in length. Change in length means final length minus initial length equals extension, right? So initial length was 0.18, which is initial, and final length is what you need to find, which is the new length. This is your new length, and this is your initial length, okay? So all you need to do is to put in LF minus LI. Then LI has to become on the left-hand side, and it will give you the final answer to be equals to 0.18 and 0.46 meter, okay? A meter rule so that it was vertical. She dropped a ball from the rest near the top of the meter rule as shown. A strobe emits flashes of light. The time interval between flashes is constant. The student photographed the falling ball using strobe lighting. The ball can be seen at different heights in the photograph as shown. For each flash of light, the student determined the distance fallen by the ball. She took one photograph using the strobe app on a mobile phone. She took a second photograph using a laboratory strobe. The time interval between flashes was the same for the strobe app and for the laboratory strobe. Each flash of light from the laboratory strobe has a smaller duration than each flash from the mobile phone. Explain how the smaller duration of each flash from the laboratory strobe affected the uncertainty in the measurement of the distance fallen. Okay, first you need to remember the strobe is like a stopwatch. The purpose of strobe is stopwatch, okay? And what is the purpose of stopwatch? Time measurement, okay? So what actually a stroboscope is, it is kind of a torch which emit light, okay? But not continuous light, it emits flashes of light. For example, you fix the frequency at 2 hertz. It means in 1 second, it will emit 2 flashes, boom, boom, okay? And these flashes will go there and come back and reflect. So you will get one image of the ball here, and you can see some of the images are blurred and some of the images are very sharp. So what's the reason? So basic purpose of the stroboscope is to image a very fast moving object. For example, this ball, the ball is moving from bottom to top. So sorry, from top to bottom. So what actually we're doing, we are actually measuring gravity, if you remember, because this is some point and this is some point. Here the stopwatch will be 0 when we start the ball to fall down, okay? And initial speed here is 0. It is like an experiment. So they're not using stopwatch here, they are rather using strobe. Strobe is a device which emits flashes of light to determine or image out the object at a very precise location. So you are emitting the flashes, and the flashes are giving you these images, right? So when you measure the distance between these two images and you use this frequency, you will get the time. And when you will get the time, you know this height. So when you know this height, you can easily find out the gravity using the formula 2s over t square. Okay. So you know this distance, you know the time from the strobe, and you will be easily able to find the gravity. Actually, this is the purpose of strobe here. Now, so strobe is falling down, falling down, falling down. You're making the images, right? Now, it's very obvious that the object is moving very fast. So you need to take the flash very quickly so that you can have a still image or a freezed image. If the duration of the flash is long, what will happen? This will happen. You will have the image, but it will be blurred because the light will take longer to reflect and come back to for the same location. For example, you have a very long duration for the flash. So that means light will travel from here and from here slowly. And when light is moving from this point to this point slowly, then it will not capture the exact location of the ball. And this will result in not a good measurement of the time, right? So it is just like a stopwatch. For this duration, you cannot set a stopwatch to 1 hour, okay? Because it will not give you the exact time, because you need here microseconds or even milliseconds, not even seconds. And if you switch it or fix it to 1 hour time, of course it is not going to help you to measure this very short time. So the purpose is for the stroboscope is to image out the very fast moving object, and the purpose is to measure the precise location. And using the frequency, we find out the distance between two images, and then we calculate the time for the travel from one place to another place. So using stroboscope, we actually find out the time of travel from here up till here. And when we do this, we will have the time, and we already know the height, and therefore we will be able to find out the gravity. So this is the background of this question. Now coming back to the question. The question is, explain how the smaller duration of each flash from the laboratory strobe affected the uncertainty in the measurement of the distance fallen. So this is quite obvious. If your flash is having a longer duration, it will create a blurred image. It means it is not a good image, or the location of the object will not be measured precisely, right? So how will you say, what will you write here in the question? You should say that the stroboscope should have a very small duration. Okay. So when it will have a very small duration, what will happen? Now let me write the answer. They're asking what will be the impact on the uncertainty in the measurement of the density. Okay. So first of all, you should use shorter duration of the strobe is preferred. Okay. Because shorter. I think I'm going to make a bullet here. I'm not going to make one because it will create sharp image, which will help in measuring correct or accurate distance. Okay. And when you have these two things in your measurements, you will automatically reduce your uncertainty. Okay. Okay. I hope you understand the answer. So if the stroboscope is emitting sharp flashes of the light, it will take a very sharp image. So when you will have a sharp image, it means it is measuring the precise location of the object. So when it is measuring the precise location of the object, you will be able to measure the distance between two sharp images as a correct distance. And when you will measure the correct distance, it will reduce your uncertainty. And if you have blurred images, of course, it will not give you the correct answer for the displacement. So your uncertainty will rise. Okay. B. The student recorded the distance s fallen by the ball and corresponding values of the time t. Explain why graph of s and t square gives you a straight line. Now, if you can take a look, what is this? This graph is actually giving you the gravity, as I explained earlier, right? So I'm applying second subat here because body is falling down, so gravity sign should be plus. It is not moving up, otherwise it should be negative. And initially the object is at 0, therefore initial speed is 0. So this term will go to 0. So half gt square, and from here you are going to get 2s over t square equals gravity. Okay. So this graph is actually giving you the gradient is actually equals to 2 times the gradient is actually equals to s over t square. Okay, so or you can say 2 times of the gradient is actually this gravity, and gravity is always constant, right? So what are you going to write? You're going to write that the gradient of the graph s versus t square is equal to a constant, okay, which is 2 into g. Therefore, whenever you have a constant gradient, you always have a straight line. Therefore, the graph is straight line. Whenever gradient is constant, the graph is always straight line. The graph is straight line. Okay. Anyways, okay. Now the second part is determine the acceleration of free fall using g. Acceleration free fall g using the student's graph. Okay. We need to find g using this graph. So let's take this point. For this point, what do we have? Okay. So this is 0.20 and this is 0.00, this is 0.04 and this is 0.00. So our gradient is going to be rise over run. Rise is 0.2 minus 0.0 and 0.04 minus 0.0. The answer for this gradient is 5. Okay. Now the gradient is actually equals to 5, and what is gravity? Gravity is actually equals to 2s over t square. Okay, so our gradient actually equals to s over t square. So we will write 2 into s over t square, or gradient. This is actually gradient. So 2 into s over t gradient, 2 into 5, it is 10 meter per second square, which is about 9.8 meter per second square. Okay, so that shows that our results are correct. Our stroboscope is working fine. Question number 15. In a high jump competition, athletes jump over a bar. An athlete has weight of 680 Newton. The athlete exerts a force of 890 Newton on the ground as he jumps into the air. Explain why the athlete accelerates upwards. You should use Newton's third law. Okay, so this is kind of a high jump. For example, someone is standing here. Okay. So its weight is 680 Newton, which is always acting downward, and he is applying additional force of 890 Newtons downward. So this is action. And what is action force? Because we have to refer to Newton's third law. Okay. So action force 890 Newton from athlete to ground. Okay? Ground or earth, you can say ground. And what Newton's second law, Newton's third law of motion says, every action force has an equal and opposite reaction force. Okay, so conditions for Newton's third law, you need to remember these conditions. Newton's third law conditions. This is not answer to this question, but it is very important for you to remember. You must have two bodies, not one body. If sum of forces on just one body is 0, it means it is not Newton's third law. It is just 0. The sum of forces 0. Two bodies must be there. Two equal forces on different bodies. Okay, equal and opposite. You can say equal and opposite forces on different bodies. Like one is applying action force on second body, and the second is applying reaction force on the first body. And therefore, when you have this kind of scenario available, it means the nature of force is same. So nature of forces should be same. These three conditions should always met in order to apply Newton's third law. Now here, the action forces by the athlete on the ground. So what will be the reaction? The action force will be equal and opposite. Equal and opposite of 890 Newton from ground to athlete. Okay. Now net forces, they are saying why the athlete accelerates upwards. This is what we need to tell. When something is accelerating upwards, it means there is some net force in the upward direction. So net force we need to find out. Net force. And this is now reaction force. Okay. Reaction force upwards. net force acting on the body. This is gone, and this is 680. Upward force minus downward force. Okay, upward force is 890, and downward force, which is weight acting always downward. So we have a net force acting on the body, which is equals to 210 Newton. And because of this force, this resultant force, because of this resultant force, the body accelerates upwards. Okay. Hope you understand that. The athlete moves horizontally as he passes over the bar. Okay. The kinetic energy of the athlete is 409 joules. Show that the athlete has a horizontal speed of about 304. Need to focus on to the words they're saying horizontal speeds. Okay. And the kinetic energy is this. So pretty straightforward. Kinetic energy is actually equals to half mv x squared because it is horizontal speed. And now you can put the value for the kinetic energy here to be equals to 409 half. What's the mass of the athlete? It was 680 Newton, right? So we can convert weight into mass by 680 Newton over 9.8 equals mass. So 680 over 9.8. This is actually mass, and this is speed. This x is the subscript. It's in the subscript. Okay, it is not something that we need to multiply or divide. So 2 into 9.8 over 680 under root. So the answer is going to be, this is how you find the horizontal component of the speed, as they said. After passing over the bar, the athlete moves down through a vertical distance of 1.4 meter before he lands. Calculate the velocity of the athlete as he lands. Now, this is a 5 marks question. It looks very easy at first glance, but actually there's a trick in this question. So here's the, when he jumps down, actually he turns into a projectile. Okay. So when he turns into a projectile, at this point, he only has the x component of speed, which was 3.42 that we just calculated. Okay. Here its y component should be 0 because the speed is totally horizontal. But here in this direction, the speed is like this. So it has x component and y component. So this x component is actually 3.42. And this y component, we don't know. Okay. So just before landing, it covers a distance of 1.4 meters. Okay. And here we don't know the final speed. First of all, we have to find out the final speed, y component of the final speed. Okay. So here, what is the final speed? This is what we need to find. Now, this is a projectile. We have the vertical height. We need to measure vertical component of the speed. So for that, we will use SUVAT, third equation, v square equals u square plus 2gs. Okay, because body is coming down, so gravity is positive. Now, which component of the speed we should use? Because body is traveling vertically, we need to use vertical component. Okay, again, the initial speed is actually equals to 3.42, right? Sorry, initial component is 0, so you need to put this component as 0 because 3.42 was the horizontal component, and while before he was just about to jump, he was horizontal, he was not vertical. So vertical component was 0 at that point. Therefore, this is going to be 0, and vy squared is actually equals to 2 into 9.8 into 1.4, and then whole under root to find out the y component of speed. This is going to be 5.24 meter per second. Okay. Now they asked you to calculate the speed of the athlete. So speed of the athlete is not only x component or y component. Rather, it is the sum of two components like v squared, vx squared plus vi, according to Pythagoras theorem. Okay. So total speed will be, or total velocity will be. So this is going to be the sum of x component and the y component. Okay. So this is 3.42 square plus 5.24 square. Okay. That will give you the final answer to be 6.24 meter per second. Okay, a simple hydrometer is a cylinder with a mass at one end. The cylinder floats vertically in a liquid. The diameter of the hydrometer is x. A scale on the side of the hydrometer shows the vertical position of the hydrometer in the liquid, as shown. A student placed the hydrometer in a sample of pure water. Complete the free body diagram below to show the forces acting on the hydrometer. Of course, this is the question of fluids. Upward motion, upward forces equal downward forces. Since there are usually three forces. One is drag force, one is upthrust, and one is weight. Okay, and drag force is purely the function of speed. Because if you see the formula for drag force, it is actually equals to 6 pi r eta v. So when your speed is 0, just like here, because hydrometer is not moving, so its speed is 0, its drag force will also be 0 because you're putting the speed to be 0. Drag is 0. So you don't need to consider this component here. You only have to consider this and this. So they're asking us to complete the free body diagram. So you need to draw equal and opposite vectors. Okay, don't make unequal vectors, otherwise you will lose marks. So if this length is 2 centimeter, make sure the upthrust is also 2 centimeter. This will be the correct free body diagram. Okay, and this is your upthrust, which is always in upward direction, and this is your weight, which is in downward direction. The student placed the hydrometer in a sample of seawater. Now it is not in seawater. Seawater is more dense than pure water. Previously it was pure water, now it is seawater. At equilibrium, the vertical position of the hydrometer was higher in the seawater than in the pure water as shown. Explain why the vertical position of the hydrometer was higher in seawater than in pure water. Well, seawater has a lot of minerals and salts, especially. Okay, so water plus salt means more dense, and it has only water, no salt, so it is less dense. And what is upthrust? Upthrust is actually the function of rho Vg. Okay, upthrust is the function of, and what is this density? This density belongs to liquid. Okay, so you can clearly see that upthrust is directly proportional to density. So when seawater density is higher than pure water density, therefore more upthrust than pure water, and therefore it rises more than pure water. Okay. Calculate the change in the vertical position of the hydrometer when moved from pure water into the seawater. Okay. In pure water, it was more in the water. The component, I mean, this submerged height this and this. Okay. So actually, they're asking you. Previously, this was more, and now this is less. So they're asking you how much of the component from here is now out of water. Okay. This is what you need to calculate. Okay. So it is a 5 marks question. So of course, it is going to be a long question. So for pure water and for C, first of all, what you need to do for what is this question? This is okay. So for pure water, for pure water, upthrust is equals to weight, and upthrust is actually equals to rho Vg equals weight, and the weight of the hydrometer is 0.324, right? Density of pure water is 997 times 9.8 times V equals 0.324. Okay, and from here the displaced volume of the pure water, I will write PW, it's going to be equals to 3.32 into 10 raised to the power minus 5 cubic meters. Okay, now same is the thing that we are going to do for seawater, because this is very necessary to calculate the volume, and when we will have the volume, we will find out that height using length, width, and height formula for the volume, or for the cylinder. I'll show you in a while, please wait. This is for pure water, and this is now for seawater. Again, we will do upthrust equals weight. This is now seawater density into volume into gravity equals 0.324, and density for seawater is 1025 times 9.8 times volume for seawater. Okay, 0.324. Now for seawater volume, we are going to get the value to be 3.23 times 10 raised to the power minus 5 cubic meters. Okay, now what is the volume for the cylinder? Volume for cylinder is, because hydrometer has the shape of cylinder, so volume of cylinder is area of base into height. Okay, now if you can take the look, this is the diameter given. Okay, and the diameter here is equals to diameter of this of the hydrometer is this. So how can you find out the volume for the cylinder? So if this is x, which is diameter, and this is height. So area of base should be circular, right? This is a circle. So area of base should be pi r square times height, which is h. Okay. So okay. This is pi and this is in centimeters, so it will be 1.23 divided by 2 into 10 raised to the power minus 2. This will be your radius, okay? So I'm going to do 1.23 divided by 2 into 10 raised to the power minus 2 because I'm converting centimeter into meters, square into height. And what is the height? This is what we need to find, okay? We'll keep it here. So now it is going to be, I'm just multiplying each and everything here, okay? So it is 11.6 into 10 raised to the power minus 5 times height. Okay. Now we have calculated the volume. Now we will apply the same technique here for pure water and for sea. Okay. So for pure water, PW equals 11.6 into 10 raised to the power minus 5 into height. What was the value for the pure water? It was from here 3.32 into 10 raised to the power minus 5 equals 11.6 into 10 raised to the power minus 5 times height. So this 5 is being cancelled with this, and the height is actually equals to 0.286 meters. For seawater, it is again this and 11.6 into 10 raised to the power minus 5 into height. I'm writing this formula again here, but only now for seawater. So putting in the value for the seawater, 3.23 into 10 raised to the power minus 5 equals 11.6 into 10 raised to the power minus 5 into height. And from here, I'm going to get the height to be equals to 0.278 meters. Okay. Now you can easily find out what is this height actually. This height is submerged in water. Okay. So for pure water, more height was submerged in water, and for sea water, it is less submerged in water. So the amount that was out of the water is actually the distance moved when you put the hydrometer from pure water to seawater. They asked you how much vertical distance covered by the hydrometer when you move the hydrometer from pure water to salt water. So of course, that vertical distance is actually equal to the amount of hydrometer's height which is reduced in the pure water. Okay, so how much height is reduced? You can easily subtract these two heights and you can get the answer. Okay, so my pen is not 0.286 minus 0.278. So this is actually equals to 8 into 10 raised to the power minus 3 meters, or simply 0.8 centimeter, or about 1 centimeter moved up. So the hydrometer moved up about 1 centimeter when you put it in the seawater. Okay. So how did you do this question? First of all, you know that up thrust is equals to down equals to weight. Using this relationship, up thrust equals weight, you find out the volume, pure water's volume, which is displaced by hydrometer. Then you find out the volume, which is displaced by hydrometer in seawater. Okay, and then you use the diameter to find out the area and volume for the cylinder, and then you find out the height of the hydrometer which is submerged in water using the volume information, and finally the height submerged in water of the hydrometer in seawater minus the height of the hydrometer submerged in pure water. You take the difference of these two heights and you get the vertical distance displaced by the hydrometer in the water, okay, when you move it from pure water to the seawater. So that is the summary of this question. A student is about to do a bungee jump from a high bridge. Bungee jump or bungee jump, I'm not sure what's the pronunciation for this. The student is attached to bridge by an elastic rope. The student jumps from the bridge and initially accelerates. The diagram shows the student at 3 different positions during bungee jump. Okay. At position A, the distance fallen by the student is equal to the original length of the rope. At position B, the student is in equilibrium. At position C, the rope has maximum extension. So you can see the student is going down there. Okay, with the rope. And they're asking you, explain how the acceleration of the student changes as she moves from position A to C. Okay, no problem. First of all, in this question, please focus that initially it is falling under gravity because the rope will not be tightened. It will be very loose. So there will be no acceleration in the body of the athlete or jumper. Okay, it will have only gravitational acceleration, right? But as soon as the rope started to stretch, there will be some acceleration started to produce here. Okay. Okay, and And now the forces, the upward force and the downward force will be balanced, and here sum of forces will be 0. Okay, so maybe he will be moving at some constant speed, and then finally there will be some net force. Because of that, the upward force dominates on the weight, therefore the body may move up again. So this is the scenario. So when a body is freely falling, the tension is 0. Okay, when tension is 0, what will you write at A? Because this is 6 marks question, so 2 marks for each section. Okay, at A, number 1, tension in the rope is 0. Okay, and when tension in the rope is 0, then only force is weight of jumper. Okay, so acceleration is only g equals 9.8 meter per second square. Okay, okay, now for B. It's 2. For B, we will say that the rope begins to stretch. Okay, so when the rope is beginning to stretch, it means there must be some tension being created. Okay, tension arrives in the rope. Arrives. Previously, it was not there because tension was 0, because no tension in the string arrives. So when tension arrives, what happens? At this point, they're saying it is in equilibrium. At here, this is B. This tension balances the weight. Balance out the weight. And when these two are 0, the sum of forces acting on the body is 0, then what should be the acceleration? When sum of forces acting on the body is 0, it means acceleration is 0. Sum of G and W equals 0. So acceleration is always 0, also 0. So acceleration is 0 as well. Okay. Now what about C? For C, now you are moving out of B and you are entering into the C's domain. T is not becoming less and less, it is rather increasing more and more. G is increasing, tension in the string is increasing. Okay, more and more. Point number 2. So when it reaches this point, it has a maximum extension. Maximum tension at C. Therefore, more upward force than downward weight. So when you have net total force acting upward in upward direction, net force applied in upward direction. So when you have the upward direction force rather downward, then what should be your acceleration? Your acceleration should be negative. Okay, acceleration is negative. Okay, this is the answer. So at A, when you're moving here A, you have G 9.8. At B, because it is equilibrium, so no acceleration. And here acceleration is there but negative, because sum of forces acting on the body are non-zero, and the total force acting on the body is in upward direction, which will bring the jumper upward in upward direction. Okay, so therefore the acceleration for C is negative. For B it's 0, and for A it's 9.8 free falling body acceleration. The bridge is above a river. The student will reach the river if the rope stretches to the total length of 35 meters during the bungee jump. Okay. The student has a mass of 65 kg. The original length of the rope is 17 meters. Okay. The rope behaves like a spring with stiffness constant of 250 Newton meter. So deduce whether the student will reach the river during the bungee jump or not. So you will consider the rope as spring, and you will consider the jumper as mass. Very nice question. And they're asking you whether this mass will reach the surface or not, which is river. Okay, so this is actually the analogy with mass spring system. Okay, so for that, now there will be two kinds of potential energies associated with this motion. At A, if you remember, at B and C. At A, the body was freely falling, so it will have gravitational potential energy. Okay, and at B, a gravitational potential energy will turn into elastic potential energy because the spring will start to stretch. Okay, so we will say that GPE, gravitational potential energy, will convert into elastic potential energy after stretching starts. Okay, so what is actually your gravitational potential energy? mgh. Okay, what is your mass and what is your height and what is your tension? This is the original length, this is spring constant, and this is the total distance from the top to the river. Okay, so for example, if he's jumping from here and this is river, so this is the total distance 35 meters. It means the height is 35. And what about mass? Mass is 65. So 65 times 9.8 times 35. So we are going to write the answer to be equals to 22,295. Okay, right. I think I need to follow another approach. An easier one. This will be a little longer. So let's do it another way. So when the stretching starts, the gravitational potential energy will be converted into elastic potential energy. So you will write it that way. Now mgh equals, what is elastic potential energy? According to strain energy, elastic strain energy formula, strain energy or potential energy is like same thing, or potential energy is actually same thing. Okay, it is actually equals to half kx squared delta x extension. Now the initial length is 17 and the final length is 35. So the extension can be easily considered as final length minus initial length. Okay, so final length is 35, initial length is 17. It means the extension is 18 meters. Okay, so we are going to write half k delta x square, right? Then what is this h equals to? This h is actually equals to the extension. Okay, that is going to be developed inside the rope, because all this gp is going to be converted into elastic potential energy. So you will write mg delta x equals half k delta x square. Okay, right? So this is going to give you 2 mg over q, right? Now the spring constant given to be 250 newtons, mass is already you have and g you already have. Delta x is actually equals to 5 meters. Okay, so we considered that all of the gravitational potential energy has been converted into elastic potential energy. So the answer for this height should be equals to 18, but now it is coming 5. It means the initial length is 17 meter. This is river, and this distance is 18 meter more extension, but the student will come up till this point, which is 5 meter more. Okay, so this will be the student's new location. So it means the student is not going to fall into the river. So how did I do this question? First of all, you need to understand that gravitational potential energy is actually equals to mgh. So m is 65, g is 9.8, and height is 35. Okay, so from here you measure the energy, which is equals to 2295 joules. Okay, then you can find out the elastic potential energy as well. No problem. Elastic potential energy is actually equals to half k delta x square. Extension is 18. So elastic potential energy is equals to 40,500 joules. This is another method. Since you can see that the gravitational potential energy is less, elastic potential energy is more, it means body will stay in upward direction. It will not go into the river because the gravitational potential energy is less and the elastic potential energy is more. Okay, so will not fall into the river. This is another method. So I will explain both one by one. When your body is falling down, it means its gravitational potential energy is converting into kinetic energy. But as soon as the stretching starts in the rope, it means all the gravitational potential energy has been converted into elastic potential energy. Okay, so I have written GPE equals EPE. Okay, if the student has to fall into the river, this length should have been equal to 18 meters, but actually it is coming only 5 meters. And I'm just putting in the values in the elastic potential energy formula and the gravitational potential energy formula. For gravitational potential energy, the measurement and the distance or the height here is actually equals to uh, the extension in the string, because for that moment it will convert into the elastic potential energy. The gravitational potential energy will start converting into elastic potential energy for that stretching. Before that, it will not. So here extension is 5 meters, okay, which is not true because the student has to fall for up till 18 meters in order to fall into the river. Okay, so in another method, this method, I have just calculated the gravitational potential energy for the maximum height, which is 35, which was coming about to be 22,295 joules. Then I calculated the elastic potential energy for the extension. Extension delta is actually equals to final length, which was 35, minus initial length, which was 17. We subtracted these two and got the extension to be 18. Then multiplied with spin constant 250 and got the value of elastic potential energy to be 40,500. As you can see, the elastic potential energy, which is producing the tension, it is in upward direction. It is more, and the gravitational potential energy, which is taking the body down, is less. Therefore, the body will stay up and will not fall into the river. Okay. I hope you understand the logic for these two questions. You can take a look for 1 minute, no problem. Then I'll move ahead. Okay. Some spiders form silk in long, thin threads to catch flying insects. Okay. Some spiders form silk and long, thin threads to catch flying insects. The Darwin's bark spider can produce very long threads. A scientist investigated the properties of these threads. The scientist applied forces to stretch threads of spider silk. The stress in one thread was 4.3 megapascals. The radius of the thread was 1.9 into 10 to the power minus 6. Calculate the force applied to the thread. So it's very easy to do. All you need to do is to put in the values in the stress formula. So stress is equals to force over area. Stress is 4.3 into 10 to the power 6. F, what you need to find, and the radius is pi r square. I mean 1.9 into 10 to the power minus 6. Okay, so we are going to do 1.9 into 10 to the power minus 6 square. This will be your area. Okay, and from here we need to just rearrange it. That will give you the answer for speed for force. This is nice. It was very easy to do. The scientist investigated a thread of length 25 meters. Determine the length of this thread when stretched to its limit of proportionality. Young modulus of spider silk is 8.7 gigapascals, and stress limit of proportionality is 300 megapascals. Okay. So you need to find out the final length, okay? The length of the thread when stretched. So they are actually referring to final length. This is what you need to find. You need to find out the final length. Initial length given to you as 25 meters. 25. Oh, my pen is not working again. So initial length is 25 meters, right? Young modulus is 8.70 into 10 to the power plus 9 pascals, and stress is equals to 300 into 10 to the power 6 pascals. So I'm applying the Young modulus formula, which is stress over strain. The strain will be taken on the other side, okay, and stress and the Young modulus will be taken on this side. Okay, so strain is change in length over original length. So stress is 300 into 10 to the power 6, 8.7 into 10 to the power 9. Delta L equals length is 25. We need to multiply that out. The answer here is 0.86 meters. Okay. Now change in length actually equals to final length minus initial length. So final length will be equals to 0.86 plus initial length was 25. So 25.86 meter is your final length. The table shows some properties of spider silk and the type of the steel. Spider silk and steel. What a comparison. The sketch shows the stress strain relationship for the spider silk up to its limit of proportionality. Okay. Add a line to the sketch graph to show the stress strain relationship for the steel up to its limit of proportionality. Okay. So you need to know that Young modulus is actually equals to stress over strain. Okay. And the gradient of this graph actually equals to stress over strain. So gradient will give you stress over strain means Young modulus, which is higher, okay, for steel. Now you can see that it is actually equals to Young modulus. Now you can see in the table, the Young modulus for the steel is higher, which is obvious that the gradient will be like this, a little higher, steeper, because its Young modulus is more. Also, the stress for the steel is more. So if this value is more and this value is more, of course the gradient will be more. Okay. So you will write since stress for steel is greater than silk and Young modulus for steel is greater than silk. So you can write stress over strain. Since this is directly proportional to Young modulus and the gradient is more, so it will be more steeper. So you will write gradient is directly to Young modulus. So for steel, if gradient is more, for steel, steeper graph than for silk. Steeper means having a higher inclined plane. This inclined plane is having like low height and this is having greater height, so it is more steep. Okay, which is having a higher angle of inclination, you can say. So this is kind of 75, you may say, and this is kind of 35, you may say. Okay. So we have explained this as well. 19. A deep sea diver is a person who swims at great depths below the surface of the sea. To help a deep sea diver moves downwards quickly, spherical masses are attached to the diver body. Okay. In order to go deep down in the sea, he attached spherical masses to his body. During a dive, one mass became unattached and fell to the bottom of the sea. State the conditions for Stokes' law to apply. Number one, since they have not mentioned one condition or two, they have mentioned conditions for Stokes' law. So you need to mention all three conditions. One, the body must be small. The flow should be laminar, and the motion will be slow motion, or the shape should be spherical shape. Okay, small radius, you can say small radius. Okay. 2, the mass accelerated to terminal velocity as it fell to the bottom of the sea. Okay, at terminal velocity the mass fell 25 meter in a time of 0.36 seconds. There was a difference of 4.6 Newton between the weight of the mass and the upthrust on the mass. The spherical mass has a volume of 45 cubic centimeter. Deduce whether Stokes' law applied as the mass fell through the water, and this is the viscosity of the water. Okay. So first of all, they have given you the distance terminal velocity. For example, from here it is falling down, and at this point it achieved terminal velocity, for example. Now after this point, the body will go down all the way to the ground or the sea floor. Okay, sea floor, having 25 meter distance covered in 0.36 seconds. Okay, so since this is terminal velocity which will remain constant, so we have distance, we have time, we can easily calculate the terminal velocity using 25 over 0.36, because this formula, velocity equals distance over time, is valid when the speed is constant. Okay, so 25 over 0.36, so terminal velocity is constant. From here we have the terminal velocity to be equals to 69.44 meter per second. Okay, now Since the spherical body is moving under the effect of weight, and now two forces acting on it, one is upthrust and one is drag. Okay, because now it is having some speed, and when a body is moving with some speed, the drag force is never zero. The drag force is always there. So we will write that the upward forces should be equals to the downward forces. Okay, what are the upward forces? The drag D, drag and upthrust equals weight. Okay, and what actually they are saying, the difference between the uh, drag force and the upthrust. You see, there was a difference of 4.6 Newton between the weight and the upthrust. Okay, so you can say that the upthrust and weight are having a difference of 4.6. You can write like this: upthrust minus weight equals 4.6. Okay, so from there you are going to get ut equals 4.6 plus w. Okay, now this is your question number 2. This is your equation number 1. You need to subtract these 1 out of 2. So you will write ut equals 4.6 plus w, and then right. No. So do we not like that? Wait, I have made a mistake in writing it. So maybe we can write the other way around. It will be better because you can write it in either way, but you have to be careful with the subtraction or addition. And the way I have written previously, I should have added them to get the final answer. So it is now equals 4.6 plus upthrust. Okay, so 4.6 plus upthrust equals weight. This is your equation number 2. Then you have to subtracting, and you will get the answer. D plus upthrust 4.6 plus thrust equals weight minus cancelled, and D minus 4.6 equals 0. So that is actually giving you drag force to be equals to 4.6 Newton. Actually, it is quite straightforward. You see, they are saying there is a difference of 4.6 Newton between weight and upthrust. So it means this difference is actually equals to drag force, right? So for example, this is weight and this is thrust. And the only thing here, the difference, which is this force, is 4.6. So this is quite straightforward that this is actually equals to drag force. But mathematically, I have shown that this 4.6 is actually equals to drag force. Okay. Now we got the drag force, we got the terminal speed. I will write it in a separate way. The drag force here, 4.6 Newton. Terminal velocity here, 69.44 meter per second. Okay, now we need to see whether the Stokes law applied or not. So if the Stokes law is applied, what will happen? What should be our answer? Our answer should be 4.6 Newton, right? Because this is equals to drag. If Stokes law is valid, then drag force should be equal to 4.6 Newton. Now let's go to it. Okay? Using Stokes law formula. What is Stokes law formula? F equals 6 pi r eta Vt. So this is 6, this is pi, and the volume is 45 for sphere. Okay, so volume is 4 over 3 pi r cube because it is sphere. So I will write 45 into 10 to the square. Cubic centimeter means cubic meters, so I will write minus 6 because I have to convert it into meters, times 3 over 4 into pi equals radius cube, and I will take the under root, cube under root. Okay, and it will cancel out, and it will give me the radius to be equals to let me calculate that. 0.022 meters. Okay, so here I'm going to put in the radius 0.022 eta, which is equals to 1.2 meter under to the power minus 3, and terminal speed is equals to 69.44. So when I calculate all of them, I get the drag force Fd to be equals to 0.0348. So when we applied Stokes law, the drag force is coming out to be this much, which is very less than 4.6 Newton, the actual force, the actual drag. Therefore, Stokes law does not apply. Okay. The graph shows how the vertical velocity v of the diver varied during a dive. The diver was at the surface of the sea at 0 seconds. Explain how the graph could be used to show that the diver reached the surface of the sea again at 82 seconds. Okay, so here is the diver. He is at the surface. Okay. Now he is diving down deep. While diving down deep, this is not the maximum depth. Okay, this is not maximum depth. Not maximum depth. Depth, it is maximum speed. So while going down, of course, there will be a point when it will have maximum speed. So this is the point where he is having maximum speed. And after that, his speed is reducing, and after that he will be starting moving upward. Okay, so this is the point, and after that the speed is reduced and he's moving, still moving down, but at a slow speed, therefore the graph is moving up. Okay, and at this point he will be at the sea's maximum depth, because here his speed is now 0. Okay, he is now at maximum depth. Now after reaching the maximum depth, he will start moving upward. Okay, so when he will start moving upward, the velocity's direction will be reversed. So previously it was negative, now it will turn into positive. Therefore, it is now moving up, moving up, moving up. And again, the velocity on the surface, when he will reach the surface, the velocity will be zeroed again. Okay. So this graph is actually giving you two kind of displacements. One is while he was moving down, and the second one while he was moving up. Okay. So the total area under the graph will be equals to 0. Okay. Total displacement, total displacement while moving down, plus while moving up. Okay, since this area is negative and this is positive and equal, therefore the total displacement is 0. So when you have the total displacement 0, then deep down the water and up while you're coming up. So when you have total displacement to be 0, it means you are at the surface, and this happens only at 82 seconds. This shows body is on the sea surface again at 82 seconds. Why not here 82 seconds? Because this shows the maximum depth deep down the sea, not the maximum, not the 0 speed means that he's on the surface. Maximum depth. Okay? This does not show that the body is at the surface. This point actually shows that the body is at the surface, because at this point the negative distance is not cancelled with the positive distance. Okay, so be careful with it. Determine the vertical acceleration of the diver at 70 seconds. Okay, this is 70 seconds, and you can see that the graph is not straight line or regular shape. So if we have such kind of conditions, then we always prefer sorry Right. Okay. So when we have such kind of conditions where the graph is not uniform or like having a regular shape, then we always choose the closest points to make it a straight line. Okay. What I'm saying, I show you now. For example, this is a curve and this is a straight line. This is point A, this is point B. Okay. This is B and this is A. You can see that A is here, B is here, equal, right? So for this gradient, I can easily take A and B, but for this gradient, I cannot take A and B because they're not making straight lines. So what if I bring this point close up till here? Okay, maybe now this is C and this is C. So for being so close, this part is straight line, and this part can also be considered as straight line, right? So this is the advantage of taking the points very close to each other, that the irregular surface can be considered as a regular surface or can be a straight line as well. Okay, so here what I'm going to do, I'm going to take these 2 points and this is the middle point. Okay, so one will be like 72 and one will be like 68, and I will take the gradient of this to get the displacement at 70. Okay, so acceleration is going to be then 72 minus 68, then speed time, which is at 72 minus 68, right? So when I do that, I need to take the values now. Here the value is about maybe Okay, let's zoom in and check what are the values. So this is 70. It is about maybe or like this. Okay. So you can say 0.24, 0.28, 0.32. It's like 0.34. And you can say this can be 0.38. Okay. And this is 0.70, this is 0.72, and this is 0.6, 68 and 72 and 70, not 0. So 70, 72, and 68. So acceleration can be equals to the gradient, right? Vf minus Vi and Tf minus Ti, initial time minus final time. So final speed is 0.34, initial speed is 0.38 over final time is 72, initial time is 68. Acceleration is going to be 0.1 meter per second, okay, square. Or you can do just a single acceleration, which is equals to 0.36, I believe, yes. So at 70, if this is the answer, I believe this is the correct answer. At 70, you can find out the acceleration directly by putting in the value of speed, which is 0.36 over 70, and find out the answer for this as well. So here's the end of Unit 1 paper, which was conducted in October 2024. If anyone out of you need any help in physics, please do let me know. My contact details are written in the description. I need your support. I need your help. Please subscribe my channel. I do put a lot of effort in downloading these papers, finding out these papers, and solving it for you. So if you give your feedback to me and if you encourage me by subscribing and sharing my channel with your friends and family members, it will be really like an energy boost for me. Okay, thank you very much. See you in the next video. God bless you and take care. Goodbye.